Hi friends and my dear students. Um, 12th physics already we studied about alpha decay and beta decay and gamma decay. In last class we have studied about gamma decay in two manner. It was in the excited state straight away transmitted to the ground state by emission of electron. Then the amount of energy are emitted by means of photon equivalent to 13.4 million electron volt. Or in other words, the excited state boron are shifted to the intermediate state. There may be emission of 9 million electron volt and carbon 6C12 star. Star means excited state. That is, it is not in the ground state, it is almost in the excited state. So, for the above example, we conclude that all the alpha, beta, or gamma decay, all the elements which are not straight away to the ground state, all are in the excited state. All are the daughter atoms almost all are considered to be in the excited state itself. The second concept. We already studied about one nucleus, one nuclei, nucleus, one nucleus, shifted of one nucleus from higher to the lower, not total atoms. Now, if you consider total atom, the total atom are in the excited state and shifted over to the ground state, then there is a possibility of electron volt, emission of electron volt. In case, if you consider the nucleus itself instead of atom, you have to consider only one nucleus shifted to the excited state to the ground state, then amount of energy received is called million electron volt. Now, we are here talking about only one nucleus and one atom. But whereas here there are sample elements are considered to be radioactive substances, the enormous samples are available, enormous elements are available. So that enormous nucleus are available in the excited state. We don't know which one is going to decay first, either first or second, third or fourth or n. If you are considered n element or n nucleus, then which one is going to decay first? We have to approximately say within the period of time, there may be disintegration of the disintegration or decay or shifting of the higher energy level to the lower energy level may be approximately calculated by probability manner. By probability manner, we can't give any assurance. For instance, suppose let us assume initially when t equal to 0, that means there is decay is not happened, then the remaining atom, remaining nucleus or nuclei is considered to be N naught. When t equal to t, then remaining is considered to be at the moment of t, the number of nuclei in the excited state are said to be n. Now, if you want to derive an expression for law of radioactivity, the disintegration dn, that is the number of nucleus are decayed in the period of dt, or dN by dt, or dN by dt is proportional to the number of nuclei at the moment. When you say dt is the smallest time, then the decay also smallest nucleus. It is happened, suppose when you say decay per unit second, then it is proportional to the number of nucleus at that moment. So that you are writing dN by dt is proportional to n, or you are putting equality constant, then alpha into n, lambda into n, lambda into n. Here lambda minus, we are putting minus sign because dN by dt, this is a disintegration within the time t, is equal to, here lambda is equal to equality constant or decay constant, decay constant, decay constant, decay constant. This is called lambda. dN by dt equal to minus lambda n. This is the first equation. You have to remember, this is the first equation. Now we are obtaining the law of radioactivity. We have derived an expression for law of radioactivity. Here first derivation dN by dt, that is equal to minus lambda into n. Lambda into n. Lambda is called decay constant. Decay constant, and n is at a time t, at that moment the remaining number of nucleus. Remaining number of nucleus. That's these things that we have to remember. Again, now we have to say or simplify this equation. Here the negative sign indicates that when the time increases, the decay speed is also decreased. Decay speed is also decreased. That's why the negative sign indicates that when you are taking a long period, then decay process may be slowly happen. Slowly happen. That's the negative sign indicates that. Now, if you want to cross multiply this equation, then dN, that is equal to minus lambda into n into dt. This is called second equation. This is called second equation. Or if you want to integrate, if you want to find the total decay of certain period, certain range, for example, when t equal to 0, the total number of atom is, there is no decay is starting, then t equal to 0, the total number of nucleus is called n0. When t equal to t, then at that moment, when the t equal to t, at that moment remaining atoms or nucleus are here n. So that we have to integrate this equation, we will get, for example, when you bring n this side, then dN by n, that's equal to minus lambda into dt. Okay, are you clear? Then both sides we have to integrate. Both sides we have to integrate. In this side, dt, time. Here, decay. When t equal to starting point, t equal to 0. Here, t, that is, t is 0 to t. It lies 0 to t. It moves from 0 to t. Here, when t equal to 0, the number of nucleus is called n0. So that n0 to n. This is the process that you must understand clearly. When there is no decay, the remaining time that is equal to re- when there is no decay, number of nucleus are said to be n naught. When decay is happened sometime, then up to the time t, then remaining atoms is said to be nucleus is said to be n. Now these equations are created in two-way process. Differential of dx by x, integral of this is equal to log x, log x, log x, that is equal to here instead of dn by n, then we have to put log n base e, log n base e, log n base e equal minus lambda into t, minus lambda into t. Then e power, as per law of mathematics, e power minus lambda into t equal to n. This is a one way that you have to derive an expression for shortest manner. But here we have to expand it as per your textbook. That's why I followed your textbook method. How can we obtain this equation as per your textbook? Here, when you are integrate this dn by n, the integral log natural. This is called natural log of dn by n equal to log n. Log n is nothing but natural log, not ordinary log, natural log. Logarithmic is default into log x base 10 or log x base e. These are all two methods. That's why here we are talking about, this is called natural log. That's why we are consider natural log of dn by n, this is equal to log n, and limit, we have to apply the limit n naught here n equal minus lambda into t. Here also we are applying 0 to t. This is the textbook method. It is also very easy. Now, when you are putting the upper limit plus lower limit minus, then natural log of n minus natural log of n naught, that is equal, when you are putting t minus lambda t, when you are putting t is 0, then everything 0. That's why 0. Therefore, natural log of log a minus log b equal to log a by b. Log a minus log b equal to log a by b. This is called in the left hand side. In right hand side, minus lambda into t. Are you clear? This is another equation. Now we want to find out the solution for this equation. We have to take both sides on exponential, that is called exponential. Then we can write e power natural log of n by n naught, that is equal to e power minus lambda t. Are you clear? We are taking both sides on exponential, that is called exponential both sides. Then exponential of natural log of n by n naught, exponential of minus lambda t. Now the natural log and exponential both are cancelled. That's why we get n by n naught equal e power minus lambda t, or we can write n equal n naught into e power minus lambda t. This is the equation for radioactive decay. Generally it may be denoted n equal to n naught into e power minus lambda t. A very good example for the radioactive law of radioactive decay equation. This is the law of radioactivity equations. Now, I hope you understand clearly. If you want to draw a graph, between number of remaining nucleus with the time, number of undecayed nucleus, number of undecayed nucleus, that is called n in the x-axis, and time in the y-axis, the time in the x-axis. When t equal to 0, then it may be n naught. When t equal to 0, there is no decay, so the total that's be n naught. Okay. When t equal to t off, so half of the time. Suppose half tk happened, remaining half tk, how much? Initially the curve like this, but it could not be cut in the x-axis because it prolonged up to infinite years, because decay never ends, it prolonged to the infinite years. That's why this curve will not cut the x-axis. That's why the curve which will not cut the x-axis. Now you want to find the how much. This is called n naught by 2. Here initially t equal to 0, then total number of nucleus undecayed is n naught. When t equal to t off, then n naught by 2. When t equal to 2t off, when t equal to 2t off, n naught by 4. Remaining this half of this amount. You have to consider half of this amount. That is called n naught by 8. This is called 3t off. Suppose if you consider n naught by 16, this is called 4t off. Likewise, it is going on, but never cut the x-axis. It is impossible to cut the x-axis because it will take up to decay happen infinite years. From these figures, we can clearly explain the relation between the undecayed number of nucleus and the time. I hope you may understand clearly. Now, next thing we are going to explain. Activity of radioactive substances. What is meant by activity or activity? Activity is called, or what is meant by activity? Radioactivity, we can also define another useful quantity called activity or decay rate, decay rate may also represent or activity. Here it is nothing but the number of nuclei decayed, for 1 second, number of nuclei decayed for 1 second, and mod of this value. We are not considering the sign, but only the magnitude. That's why we are putting the activity or decay constant or decay rate R is equal to dN by dt. dN by dt, that's equal to R, that's equal to dN by dt. We already studied about dN by dt is nothing but lambda dN by dt is nothing but lambda n naught e power minus lambda t. We already derived an expression. Or you can say lambda into n is equal to n naught into e power minus lambda t. That's why I have to substitute the value of n here so that we get dn by dt, mod of dn by dt is equal lambda n naught e power minus lambda t. This is the decay rate or activity of or simply you can write this is a constant, this is called r naught. Here r naught is nothing but when t equal to 0, the activity equal to r naught. When t equal to t, the activity become r. That's the thing that you have to understand. When there is no decay, then the activity equal to r naught. When after t second, the radioactivity activity r is called r. Now r naught into e power minus lambda t. This is a very fantastic phenomena that you have to understand. Are you clear? Next, we are going to finish this equation. When r naught equal to, what is the value of r naught in this equation? R naught is nothing but lambda into n naught. We can get this value here. R naught equal to lambda into n naught. Therefore, we can write from this equation n naught, n equal to n naught into e power minus lambda t and r equal to lambda into n naught, then we can write instead of lambda n, you have to put r naught into e power minus lambda t. Therefore, we can write r that is equal to lambda into n. R that is equal to lambda into n. How can we write lambda into n? Because if you write r equal lambda n naught e power minus lambda t, this is nothing but n. Or you can write lambda into n. This is a fantastic equation, that is radioactivity or decay rate is the product of decay constant and remaining undecayed nucleus. This is the product of these two things is equal to radioactivity. This is a very important equation. This is the very important equations to express the law of radioactivity. From this equation we can say the unit for radioactivity is called Curie or Becquerel. Both units are utilized to indicate the radioactivity. Here, one Curie that's equal to 3.7 into 10 power 10 decays per second. Decays per second. Or this may be called Becquerel. This may be called as Becquerel. Therefore, 1 Curie equal 3.7 into 10 power 10 becquerel. This is the famous equation that we are obtaining from the law of radioactive substances. This is the equation, law of radioactivity, and this is the equation, activity or decay rate. Decay rate is the product of lambda and n remaining undecayed nucleus as well as decay constant. This is a very important 5 mark question for your annual examination. I hope you understand clearly. If you have any doubt, then you have to put comment my channel. If you are liking my channel, please subscribe and refer to your friends, and also put all comments. Then every my classes reaches to you. Thank you, my friends.